Hello, in these lessons we are going to apply the ASTC formulas to evaluate trigonometric functions for any angles. The four quadrants of the Cartesian axis are as follows. So the theta is in the quadrant 1 and the theta is in the quadrant 2, and this one the theta is in the quadrant 3, and this one the theta is in the quadrant 4. So we notice that theta is the angles of the interest that we are going to find, and alpha is an acute angle that is less than 90 degrees. The acute angles alpha, which is measured from the x-axis, is also called as a reference angles. We are going to use the concept of reference angles to evaluate the trigonometric functions for any angles. Before we proceed, let me show you how to find the reference angles alpha in any quadrant. For example, when we have the theta 120 degrees, which is in second quadrant here, so to find the angle alpha, we may use the 180 degrees subtract with 120 degrees, we will get the reference alpha of 60 degrees. So for second examples, we have the theta equal to 300 degrees, which is in the fourth quadrant here. So to find the reference angle alpha, we may use the complete rotation 360 degrees minus with 300 degrees, so you will have the alpha of 60 degrees. When theta is 520 degrees, so we notice that here is our 520, which is in second quadrant. So to find the reference angle alpha here, so we may use from a complete rotation is 360 until here is 540, so you may use the 540 minus with 520, so you will get the 20 degrees of reference angles. Based on the following diagram, we are going to show you how to find the reference angles and the signs of the trigonometric functions based on the signs of the coordinates x and y. In the first quadrant, we notice that the reference angles alpha is equivalent to the angles theta. Since both x coordinates and y coordinate are positive in the first quadrant, so all the functions are positive. We look at the second quadrant. So here is the alpha. So we notice that the reference angle alpha is equivalent to 180 minus with theta. In the second quadrant, the x coordinate is negative and the y coordinate is positive. Therefore, sin theta is positive and cosine theta and tangent theta are negative. In the third quadrant, to find the reference angle alpha, we have to use theta minus 180 degrees. In the third quadrant, both x coordinate and y coordinate are negative. Therefore, sin theta and cosine theta are negative and tangent theta is positive. In the fourth quadrant, the reference angles alpha will be 360 degrees minus the theta.
Since the coordinate x is positive and the coordinate y is negative,
and for these quadrants, only cosine is positive, sin theta and tangent theta are negative.
we may apply this knowledge to evaluate trigonometric functions for any angles.
We may use the ASTC formulas to remember the signs of trigonometric functions. So in the first quadrant, so all is positive, so is A. In the S is second quadrant, sin is positive. Third quadrant, T, tangent is positive. In the fourth quadrant, C, cos is positive. So we may use the phrase a smart trigo class to remember this. So we try to evaluate each trigonometric functions here using the reference angles. So we have the questions A, cosine 240 degrees and cosecant 11 pi over 4.
Since we know that the angle 240 lies in the third quadrant, so we may have our reference angles alpha here. We find it by using the formulas theta minus 180. So we will have 240 minus 180, so we get the 60 degrees as our reference angles. After that, we use the formula of ASTC. So we notice that in the third quadrant, only tangent is positive, so the cosine is negative in third quadrant. Therefore, the cosine of 240 is equivalent to negative cosine of 60 degrees. So you will have the negative 1 over 2.
Look at the questions B with the cosine 11 pi over 4. The angle 11 pi over 4 lies in second quadrant. So the reference angles alpha is here. So to find the reference angles, so we notice that you may use one complete circle is 2 pi, and we proceed with another half circle, so it's another pi here, so we have the 3 pi here. So therefore we may use the 2 pi plus pi minus theta for the reference angle. So we have the 3 pi minus 11 pi over 4, so we will get the value of pi over 4 as the reference angles alpha. After this, we proceed with the formula L is positive, ASTC. So we notice that in the second quadrant, sin is positive and the relations of cosecant theta is equivalent to 1 over sin theta. So if sin is positive, cosecant also positive. So cosecant is positive in second quadrant. So therefore, cosecant 11 pi over 4 equivalent to positive cosecant pi over 4. And is equivalent to 1 over sin pi over 4. From the value of special angle sin over 4, it will be 1 over sec 2. So therefore, you will have equivalent to sec 2.